In this video, we are going to work through the following problem. We want to compute this indefinite integral. All right, so looking at this integral, it's not one of the basic ones, which is, basically just a derivative fact in reverse. And so sort of the next thing, kind of step up from the basic derivative fact, is going to be integration by substitution. And so for integration by substitution, what we're going to do is to choose a value for u. So we're going to set u equal to some parts of the integral here. And if you think back to the video I made about substitution, I said one of the top choices for u is going to be things that are parts of the expression that are inside other parts. And so looking at that, this ln x plus 3, right, is definitely looks like it's inside this other part of the expression. So that is probably a good choice for u. All right, so that's what we're going to go with. And what we're going to do is set u equal to the natural log of x plus 3. Okay, and once you make that choice, then the next thing that you're going to do is to calculate du. All right, and to do that, what you want to do is to take the derivative of this. And so the derivative of the natural log of x is 1 over x, and then plus the derivative of 3, which is 0. So that would be 1 over x plus 0. So just 1 over x. And then don't forget to multiply that by dx here. And remember, as I mentioned in the previous video, this is just going to help you to transform this integral correctly. All right. And so now looking at this, what I want to do is to change every single occurrence of the variable x here over to an occurrence of u using these two rules. And you can adjust these rules as you need by multiplying both sides by a constant. And that's generally the main thing that you would do, although there are other things that are possible to do. So what I'm going to have to do is to go through and pick apart this integral and see how can I use these equations to transform these to u's. The thing that you picked to be u is generally pretty easy on the simpler problems. So you can see I picked ln x plus 3 to be u. Well, that means that all of this stuff that's inside parentheses here is just going to be a u. Okay, so that's what I'm going to do. So this top part here would be u. Oops, before I do that, I don't want to quite do that yet. I still want to kind of look at this. All right, so this top part would be taken care of by this part here. And then I have x on the bottom part of this fraction here and the dx. Obviously, you're going to use this dx over here to transform this, the dx part into du. And you can see I have this 1 over x over here. I have 1 over x dx, and I have this x on the bottom. And so what you can do is sort of pull this integral apart. In other words, rewrite it as a product like so. And now you may say, hey, well, wait a second, it's not entirely clear that those are the same expression, but if you think about it like this, I can always write this as a fraction, and then to multiply these two fractions, I would multiply the tops together. That's the natural log of x plus 3 quantity squared times 1. That will give me just the natural log of x plus 3 quantity squared, like up here. And then if I multiply the bottoms together, I get 1 times x is x, which is exactly what I have here. So multiplying these two fractions together is going to give me exactly this expression up here. And then once you pull it apart like that, it's a lot clearer as to the substitutions that you're going to make. And so now we can go ahead and do that, right? ln of x plus 3 quantity squared, that's going to be u squared over 1. And then 1 over x dx, that's going to be exactly the same as du. So I can replace 1 over x dx, right, with du. And you can see how that kind of works perfectly here. If you recall back to the video that I did about substitution, the general video, I said another good choice for things for another good choice for u are things whose derivative appear as a factor in the integrand here. And on this problem, it's a little bit hidden, right? Because here it looks like x is in the bottom part of the fraction, but you can pull that apart, and now you can see that the derivative of ln x plus 3, right, 1 over x, does exactly appear in there. So that also confirms, that was probably a good choice for u. But sort of the ultimate test is, did the integral, now the u integral, come out to be simpler than the one I started with? And it absolutely did, right? Now this one is just a basic power rule integral, and so we would just use the power rule to take its antiderivative. And so the antiderivative of this, we would add 1 to the power, so that's u to the 3rd power, and then either divide by 3 or multiply by 1 over 3, right? Like so for the power rule. And then don't forget, we're talking about an indefinite integral, so don't forget to put the plus c here. All right, so we have the most general antiderivative, or the indefinite integral of this, but we have it in terms of u. And the last step here is what is to back substitute. We want to express this indefinite integral, right, in terms of the original variable, and that's with x. And so that's pretty easy, because all we need to do is to take what u is equal to, ln x plus 3, and plug it back into this expression here. So the final answer on this one will be 1/3 times the natural log of x plus 3 quantity cubed plus some constant c.